Okay, hot air balloon question. You've read the question. Here's the diagram that I've started here. The wind's blowing. The tether is 300 meters long. Nice air balloon. Makes 60 degrees with the ground. They shorten the tether to 200 meters. It makes a 45-degree angle with the ground. What's the difference in the horizontal distance traveled? The difference in the distance of the horizontal travel. So basically, we want to create a right triangle here. We've got a 45-degree triangle. Well, if we have a 45-degree triangle, that means that we're dealing with the 45, 45, 1, 1, and root 2. Okay? We've changed our 200 from root 2 to 200, so we've amplified here. We've made our triangle a lot bigger. Okay? What we want to do is find the horizontal distance. So let's call this distance 1. Using this 45-degree triangle and the 200 meters, all I have to really do is look at my 45-degree angle. This is the adjacent side, this is the hypotenuse side. So adjacent and hypotenuse, according to silly old Henry, carried a huge tub of apples. Adjacent and hypotenuse is my cosine, right? So I have cosine 45 degrees equals the adjacent side over the hypotenuse. And now I just have to isolate D1. Because I know that the cosine of 45 degrees, from my special triangle, cosine of 45 is adjacent over hypotenuse, is 1 over root 2. Isolate D1, so multiply both sides by 200. So D1 equals 200 over root 2. That's my first distance. Second distance comes from this triangle. The second distance, D2, comes from my 60-degree triangle. 60, 30. Right adjacent to my 30 is root 3. 2 is always on the hypotenuse, just like the other triangle. This one's 1. Okay, because we're trying to find, according to the 60-degree angle, the adjacent side over the hypotenuse. So D2 over 300, adjacent over hypotenuse, again is cosine. Cosine of 60 is my adjacent side over the hypotenuse. Cosine of 60, according to this triangle, is 1 over 2, adjacent over hypotenuse. Multiply both sides by 300. 300 times 1/2 is 150. What's the change in distance? Well, the change in distance is the difference between those two ratios that we have here. Or two, I guess, distances, sorry. So according to my picture, it looks like D2 is longer. Okay, you could actually plug that into your calculator. That's what it asks you to do in the last question here. So I'm just going to double check to see how long 200 divided by 2 root actually is. And it's 141. So I am correct. 150 is longer. So if I want to find the difference, that's what I'm trying to do here. The difference is D2 minus D1. So 150, take away 200 over root 2. That's what it's asking me to do here. So it's asking me to find the exact expression for the horizontal distance. Okay, so instead of, well, that would be an exact, but we really should get a common denominator and fix this up. So my denominator here is 1. If I want a common, this would be a root 2, so I have to multiply by root 2 on the top. So I have 150 root 2 minus 200. The denominator only gets written once. That would be an exact value. Okay. All right. So that is the horizontal change in distance. Use meters, use a closing statement. Okay, write it up nice. And question C just says type that into a calculator like I've already done. Okay, good luck in your test tomorrow.